Okay. Once more, hello, dear students. Glad to hear you. Today, we will continue our short revision about previous material, what we were speaking before the break in our educational process. The main question, what should you remember for this time? What was the main points that we discussed in previous lecture? What the main points that should be inside your brain? First of all, that we have three main laws, and all our mathematics grounding on these three laws. It is the Ohm law, connecting voltage, current, and resistivity of any active or passive branch. The second one, it is the current, Kirchhoff law, the law for current, that the total current inside node equals 0. That is mean that total current that inflow equals total current that outflow. It's just a continuing of charge conservation law. And the last one is a voltage Kirchhoff law that tells us that inside any loop, inside any closed mesh, the total voltage equals 0. That is mean that the total voltage of all sources should equals the total voltage of all consumer. It is also transformation of general physical law, the transformation of energy conservation law. It was three main laws that we discussed. Also, we discussed topological elements inside electrical circles, how we build the mathematical model of some electrical system, and which characteristic, what characteristic has this mathematical model or has this electrical system. Also, starting from this law, we discuss couple mathematical transformations, how we could use them to calculate electrical circle, to calculate electrical circle. It's mean to find all voltages, currents, and powers on any elements, just to determine what is the working mode of this system. And to these mathematical approach, to these methods, we discussed previously the method of application of Kirchhoff's law. Using Kirchhoff's law, we just making equations to find these values. The second one was mesh method, mesh current method. We are starting from current and then trying to find everything. And the last one that we finished previous time, it was voltage method, or potential methods. It's better to tell as a potential method. It grounding on finding the electrical potential, the energetic characteristic of point for all points of our system, for all nodes of our system. It was three main methods. And about our mathematical model, what we are discussing direct current, that our sources produce direct current, not sinusoidal, not any alternating current, not any, for example, exponential or other type, just case of direct current. also, it is our assumption to build mathematical model. We are building model and assume all elements as linear. It means that they are all constants. Just we could specify resistivity that is just a number, not a function for each element. All elements are constants. And also, we neglect any spatial parameters. We neglect that our system, our element inside system has any spatial dimensions, has any lengths or something else. We just represent them as a material point, just as a point which has this resistivity. And also what we could say that all process appears later in time. We neglect any, for example, transient process, any switches inside system. We neglect all this. We just thinking that all elements inside our system working in ordinary mode, which appears long time ago. It just called state process. State process. I think that's all. That is our main assumptions. Yeah, that's all. Our main assumption. Today we just going further, try to look through what we have for the next mathematical operators, for the next methods, why we using different methods, just to simplify our calculation. Because in some situation, one method is simpler, in other situation, other method is simpler. What does it mean simpler? It means that this method gives us opportunity to decrease the number of necessary equations. The less number of equations that we could get, it means the simplest method. Okay, for today, in which direction we are moving further? We have some transformation, some simplification. I think let's better see it on the list of topics. We finished on topic number 7. In previous short lecture. Then today we will discuss some equivalent transformation. It means to simplify circle using some the best word is transformation. Using some transformation, or instead of some part of system, we are putting other simpler in resistor number or in general elements number, other part of system. It is yes, transformation. It isn't just other method, just another method. It just could say that useful thing that we could use inside any other method. It's just some additional part of method, not just the complete whole new method. Then the fifth, it will be this transformation. We could use just as additional part of any other method, just to substitute in previous method. Then we will discuss equivalent, and then we will discuss superposition theorem, the method number 4, and Thevenin theorem. Or in other words, it's called equivalent generator. Equivalent generator. It means the more simple circuit of generator which we could substitute instead of more complex case. In case of lots of generators, we could substitute all of them as just one with simple electrical circle. And this is the general picture of direct current of all that we discuss and all that is better you for remember. It is everything connecting to DC. Then we will move, I think it will be next, on the next class, on the next lecture, we will move to alternating current. And we could use all main laws, all main methods into alternating current case. In this case, only alternating current mathematic will appear, but other assumption as linear elements, neglecting of space dimension and state type of process, it also will be present. It stays, them stays the same. And only one difference that will appear in DC. We are using constants, just numbers. For example, the current is 5 amperes. But in alternating current case, we are using complex numbers, complex vectors. Why it's so, we'll speak next time. But we will tell that our current is, for example, 5 plus J5 amperes. We'll use complex numbers instead of constants. It will be only one difference between alternating current and direct current case. Okay, then it is general picture for you to see the whole course that we will discuss. Then for today, let's return to our material. We'll make quick revision of equivalent transformation. What does it mean? Superposition theorem and equivalent generator method, or the Thevenin theorem. Two methods based on some theorems, and one useful thing as called equivalent transformation. It is our plan for today. If you have any questions, please welcome. If no, then just we'll continue. Okay, and I think if you are keeping silence, then everything is okay. And there is no question. Okay, then let's move to the equivalent transformations, starting from 54 page. Here it is. Everything that we are doing here is just for decreasing the number of elements or making the position of elements more comfortable for making mathematical equations to calculate them, to calculate the state of this system. What this transformation could be? The first transformation, we discussed it before the educational break. It is transformation that called star delta. It means that if we have specific type of connection of elements using specific formulas, we could transform one part to another part. For example, if we have such type of connection that is called star in this form or in this form, it is the same connection. It has, let's make other color. The same connection. It has general point for 3 elements. And other points, they are just connecting to other part of system. T connection because it looks like T letter, star connection because it looks like star. Also, sometimes it's called Y connection because it could be look like English letter Y. It all the same object, but different names depending on literature, depending on the informational source. The main characteristic that you should have central points in which 3 resistors are connected. They are all in the same situation. And the other second type, it's called P or delta connection because we have like a triangle. Also, it's called triangle connection because we have 3 points in each point, 2 resistors are connected between each other. In first point, resistor 1 and 2, in second point, resistor 1 and 3, and in third point, resistor 2 and 3. If you look on P connection, it is the same because 4 and 3 just looks like 2 different points with 0 wire between them, but the potential will be the same, and it is the same case that you are connecting resistor 2 and 3 just in one point. Because if you are connecting single wire without any resistivity, it will be the same potential and it will be the same point as connecting just directly. But because it looks like P letter or Russian letter P or constant, Pythagoras constant P, that is why it's called P connection. Looks like triangle, it's called triangle, or looks like Greek letter delta, sometimes could be called as delta connection. And using formulas, you could in any system transform star connection to delta connection, or you could transform delta connection, return to the star connection in any situation. How it could be applied? For example, here on practical example, as you see, you have lots of connections of this type. If we're speaking about star connection, you have one star here, with central point, and other star here, also with the central point. Also, you have star here, the third variant, also with the central point. And if we are speaking about delta connection, you have two types of delta connection here. First connection, like this, with points A, B, C. And the second type of delta connection, it is here. That is mean that you have at least 5 variants how to transform this system in other view. You could use any type of this transformation. You could use any type of these variants, but let's see that here is 5 types of this transformation. How it is made? For example, if we want to transform upper delta case, this part, first of all, we should redraw all other part of system, just redrawing it in the same way. The points A, B, C stays on the same points inside system, and instead of delta, instead of looks like triangular system, because 3 resistors connected all together, we should draw the star connection, 3 resistors connected in 1 point. It is here. Also, other variant, instead of bottom triangular part, we could obtain the other star transformation, redrawing all other part of our system, leaving the main points on their places, and on this point, drawing our star connection, the connection with central point similar to all 3 resistors. For example, it is 2 variants of delta to star transformation. Also, just one moment. Also, what we should mention, that if we are transforming some part of system, if we are transforming some delta part to a star part, we should change the resistivity of our consumers, because if it is a different type of connection, that it means that we should use different resistivity of these objects. If it was 8, 14, 26, in our, we are using transformation of uppercase. Transformation of upper part. If we had 20, 18, and 8 ohms of resistivity, instead of them, we should put 7.8, 3.5, and 3.1 ohms of resistivity. How we get it? Why the numbers should be just like that? We have formulas, direct formulas of this transformation. For delta to star transformation, for this case, we have this part of formulas. And for reverse transformation from star to delta, we have the second type of formulas. Just using them and obtaining new numbers. How it is working, let's see. If we have 20, 18, and 8 ohms in delta, and we want to transform to the star, it is the first part of formulas. We should calculate like it written here. We should put in upper part of equation 20 and 18, for example, and divide on 20 plus 18 plus 8. It will be the first resistor. The second resistor will be 18 multiply on 8 and divide on the same bottom part of ratio. It will be 26 plus 20, 46. And the last one will be 8 multiply on 20 and divide on the same 46. Let's calculate, let's check that the number will be the same. 20 multiply on 18 divide on 46, it will be 7.8 or 7.82. 18 multiply on 8 divide on 46, it will be 3.1. And 8 multiply on 20 divide on 46, it will be 3.5. Let's check it. If we see the same situation, one resistor will be 7.8, one resistor will be 3.1, and one resistor will be 3.5, the same numbers. That is how we get them. Using the initial star part and recalculate new numbers of resistivity to obtain the new circle with star. It is how it's made. Please, is everything clear about star and delta transformation? Is it okay how we did it?
Yes.
Okay, perfect. Then, using the same example, the same. Yes, please. Could you repeat?
What about number C, the C drawing?
Okay. The C, yeah, thank you. For question, the C drawing, it is further transformation of B drawing. We are looking further. Just one moment. We'll take color. We see that couple of resistors connected serial, and we could add them using serial connection. We could add 3.1 and 14 into 17.1, and we could add 3.5 and 10 as 13.5. Then these two branches are in parallel because they have the same points. And we could add these two branches in parallel as 13.5 multiplied on 17 and adding these two numbers as a formula of parallel connection. And after it, instead of 4 elements, we could obtain a single resistor as 10.1 as almost 11 ohms. I think formulas should be here. It's for picture B of transformation, and then for our simplification of circle, I think let's do like this to see the calculation and drawing in one window. Yeah, here it is. The first calculation for transformation, the second calculation as we discussed. Adding serial connection, here it is, the pairs of resistors, then take them in parallel, obtain the whole one, and then we could add all 3 resistors near source as 10 plus 7.8 plus 10.8 to obtain the total number and find total current near the source. The total resistivity of this whole system equals 28. It means 28.7. It means that the whole resistivity of all these elements in primary case should be the same 28.7 ohms, and the initial current near the source will be about 0.7 amperes. It is the final solution of this example. Please welcome maybe some other questions about this example. Okay, perfect. Then it was the example of first type, delta to star transformation. We could also check the second type, star to delta, find any star in this case. For example, let's use this star and let's transform it to delta. How it will looks like? It will be the same circle, the same source, resist, other 2 resistors, and the points A, B, and bottom point without name, let it be D. The same points A, B, and D. And we'll connect delta instead of star. The delta will look like here, like a triangle with 3 points of connection. If we'll redraw it, you see that it looks like triangle. Here it is. And we could recalculate these 3 resistors, use instead of them other 3. How it will be using these formulas. Let's check. What should we do? We should take, for example, I will move it back. Here it is. We should use, for example, 2 resistors 18 and 8. Using the second type of formula, it will be 18 plus 8 plus 18 multiply on 8 and divide on the last one, 14. Then let's calculate 18 on 8 divide on 14. It will be 10.3 plus 8 plus 18. It will be 36. The first resistor between points A and B, because we use 18 and 8, it will be 36.3. 36.3. And using the same formulas for other. We should take 14 multiply on 8 divide over 18 plus 14 plus 8. It will be 28.2. And then the last one, 18 plus 14. 18 multiply on 14 over divide on 8 plus 14 plus 18. It will be 63.5. And after that, we could calculate the total resistivity. First of all, we could take 2 resistors in parallel here, 2 resistors in parallel here. It will be 20 parallel to 36.3. Let's draw the new circle just to see the difference. The source, the resistivity 10. And then instead of these two will be formula for parallel connection, 36.3 multiply on 20 and divide on their sum. It will be 56.3. Almost 13. It will be 12.9. Then instead of bottom 2 parallel case, 28 in parallel to 26, it will be 28.2 multiply on 26, divide on their sum, it will be 54.2. It will be 13.5. And the last one, the previous resistor from a triangle, 63.5. Then you could add in serial 12.9 and 13.5. It will be 26.4. And take in parallel them to 33.5 as total resistivity. It will be multiply on 63.5 and divide on their sum, it will be 89.9. It will be 18.6. Then it is mean that you have your source, voltage source, sorry. You have your source with 10 ohm resistivity, and the total resistor, instead of all of them, 18.6. And if you will check solution, here we get 28.6 altogether. And in previous case, we also obtained 28.6 altogether. The total resistivity, we obtain the same independently which type of connection we are using. As you see, we could use delta to star connection or reverse star to delta connection. It independently appears as the same resistivity, the same answer. That is mean that you could use any of it. The main difference, which is simpler for you. Please, if you have any questions about reverse transformation, about star to delta, please welcome. The reverse transformation to the star, to the delta, to the triangle. Is everything okay?
Professor, can you repeat the last part? How you added the numbers?
Which numbers? All of them or some specific numbers?
No, the first drawing.
The first drawing here, the right
Yes.
one. Okay, we obtain numbers using their formulas. Because if we had this blue one star, and we want to obtain this red one delta, then we are using formulas from star to delta. This one, we are taking numbers from the primary formula. If we want to find one part of triangle, one part of delta between points A and B, we are taking resistors between points A and B and substitute them in this formula. It will be in ratio 18 multiply on 8, these two resistors, divide on this last one, on the third one, divide on 14, then adding 18 and 8, these two resistors, just substituting in this formula.
Okay, Professor. In the formula it says R1, R2. R2 is,
okay.
Is not 8.
Okay. I understand what you mean. Because general formula takes not a specific index of resistor, but its specific place on the circle. This formula is written for the drawing. Just one moment. For drawing number 7, this one. And in this drawing number 7, we have resistors 1, 2, and 3. Because for simplification, we don't write any other. And this second resistor is different from the second resistor in figure number 7, because these two different examples. Just one moment. Yeah, two different examples. And if we want to write this formula in general case to our specific case of example 7.1, it should look like sorry, some or some technical problems. Okay, what should we write in this instead of this formula for our specific case? Generally a nice question, because I should mention it. You should write to obtain resistor between points A and B. Let's call it AB. You should take resistor between these 2 points. It is R3 and R6, and it will be R3 plus R6 plus R3 on R6 and divide on R4. Because we are looking not on the index numbers, but on the placement, on the appearance of these resistors in the circle. What is their disposition in our transformation? Okay, for now it became clear.
Yes.
Okay, yeah, thank you for a question. Please, any other, if you want to ask. Okay, then let's think that everything is clear. Let's move further. This is a continuing of the example. After we found the total resistivity, we could find all currents in our circle, all currents in all branches, and also check power balance using these currents. Our main goal just to find the first one, because it gives us opportunity to find everything else. As we found the first one, let's return to our circular model. If we have the first one and found current number 2, then we could do anything. We could find the deviation of this current in different branches, find current number 1, find current number 4 using proportion. If current number 2 divides into the current number 1 and current number 4 on the picture B, this deviation will be straight to the proportion between resistivity. That is why we are taking the proportion of resistivity, how one branch equals with other branch, and found that the total current 0.7 divides as current 0.25 and 0.44, 0.26 and 0.44. Altogether will be 0.7. After it, we could find voltages between points AB and BC. Just to return to our primary case, let's draw what we found. First of all, after total resistivity, we found current number 2. Then using proportion, found that this current divides as current number 1 and current number 4. Here they are in our initial circle. And at the last, we should find current number 5, current number 6, and current number 3. How they should be found? Using voltages. This current equals voltage. For example, current number 3 equals voltage AB divided on resistor 3. That is why if we will find voltage, AC, if we will find voltage AC, we could find this current. The same is for current I6. If we will find voltage BC and divide it on R6, we could find I6 current. And from voltage AB, we should find current I5. It means that from the star after transformation, we should return to our triangle, to voltages in our triangles to find these currents. This is how we do it. We are looking for voltage AB and BC. In our star case, how to find voltage AB? To add voltage, let's point central point, for example, as O or 0. We should add voltage A O plus OB, and we will take voltage AB. The voltage AO equals current on resistivity. The voltage of OB also current on resistivity. Adding, obtaining voltage AB. From voltage AB, finding current I3 here. Then doing the same, voltage BC from voltage OB with negative sign because of opposite direction, and voltage OC. To find BC, taking BO with negative sign and plus OC. From this voltage, finding current I6. Just I draw the same colors to see the part of system that we're using for the same values. And the last one, the fifth current number 5, we could find just using the Kirchhoff law, or we could use the part of triangle, or we could use the first Kirchhoff law, because 3 currents altogether should equal 0. And we could use nodal form of equation for current to find them. And here it is how we found all currents. From 6 currents in our primary case, we could find power balance. We have only one source, multiply our electromotive force on the current, general current I2. It will be about 14 watts of generation. And joule heating of all resistors, square of current multiply on each of resistivity. We have 6 resistivities. Then we should add 6 joule heating as square of current for each resistivity on the value of each resistivity. after accurate calculation, the sum of these 6 parts also will be about 14 watts. And we obtain the power balance equation, the energy conservation law, that from 14 watts generation, we obtain 14 watts of consumption. That is mean that everything is okay. Just at home, you could revise this example. It is quite detailed. Example number 7. It is quite detailed. You could look through it at comfortable atmosphere at home. And if will be any questions, please welcome. You could text me or ask on the next lesson. Please, no problem. For now, generally we discuss everything that planned. Next time we will move to the last 2 theorems as superposition and Thevenin theorems. For the delta and star transformation, please, if you have any question before the break, you could ask.
Professor, can you send us this recording, Telegram?
Yes, of course. I will send or the link on Google Disk or the link on YouTube if I can download it. I will download it for some spacement, and yeah, sure, we'll send link for the previous lecture and for this one.
Yes, okay, thank you.
Welcome. Any other questions? Okay, perfect. Then thank you for your attention. Wish you a nice day, and see you next time, next week, the same 9 o'clock Ukrainian time. Once more, thank you for your attention.
Thank you, Professor. Have a good day.